Hello guys, welcome back to another video. Today we will see another application of prefix sum, which is subarray with zero sum. Okay, so we will move on to the question. The question is, given an array of positive and negative numbers, find if there is a subarray of size at least 1 with zero sum. Okay, let's take an example. So here 4, 2, minus 3, 1 and 6. And 5 numbers. Okay, so output is yes, as 2 minus 3 and 1 is the subarray with some 0. Okay, let's take another example. Input is 5, 4, 2, 0, 1, 6. Yes, there is a subarray having some 0, so there exists a subarray with some 0. Okay, so here the first approach comes to my mind is we will check every subarray of length 0, length 1, length 2, length 3, length 4 and check if the sum is 0 or not. That would be an n-square approach. That is not feasible here, as we have to devise a solution of time complexity order of n. So here a hero comes into the picture, that is prefix sum. Okay, so how will we apply this? Wait, I will show you. So here we can see, if we take this example 4, 2, minus 3, 1, 6, 4, 3, minus 3, 1, 6. Okay, so now we will find the prefix sum of this array. Okay, so the prefix sum of this array will be 4, 4 plus 2, 6, 6 minus 3, 3, 3 plus 1, 4, 4 plus 6, 10. So here we can observe one thing, that the prefix sum repeats, then there is an existent subarray whose sum is 0. Okay, so here we have a subarray having sum 0, that is this. So from this conclusion, let's take another example and see if it is true or not. Let's see 4, 2, 0, 1, 6. Okay, so here we have 4, 2, 0, 1, 6. Let's find the prefix sum of this array. So prefix sum of this array will be 4, 4 plus 2, 6, 6 plus 0, 6, 6 plus 1, 7, 7 plus 6, 30. Okay, so here we can see the prefix sum repeats. Hence we can say that there exists a subarray with some 0. Here 0 is an element, so this is only a subarray with some 0. So here we can conclude that if the prefix sum repeats, then we can say there exists a subarray with 0 sum. Okay, so this is order of n approach, but with time complexity order of n and space complexity also order of n, as we have to find the prefix sum array and store them. So let's move on to the code. Here is the code. That is a normal procedure of finding the prefix, initializing the prefix of 0 to ARR of 0 and finding the prefix sum that we have seen in the previous videos. You can check it out. Now we will use dictionary to search if this 6 repeats or not. Okay, so 6 repeats or not, or 4 repeats or not. So here we have created a dictionary, and as we can use hashing so that we can search in order of 1 time, that is why we are using this. So if j equals, okay, so one edge case is remaining. Suppose we have an array, suppose let's say 10 comma minus 10. Okay, so the prefix sum of this array would be 10 and 0. Here we can see that no element in the prefix sum repeats, but at last we are getting 0. So this we have to handle. This is the edge case of this problem. So here we have handled this using if j equal to 0. Here j equal to 0, then we will return true as there exists a subarray. Else, if the prefix sum, the element in the prefix sum repeats, then we will say true, or else after all the iteration, if a prefix sum, if element in prefix sum does not repeat, then we will return 0. Okay, so let's compile this code and see what will be the output. So we are getting correct output on this input. Let's submit the code and check if our solution is right or not. Yes, our solution is right. 431 of 431 test cases passed and in the time limit. So this is the approach how we will solve the question. Thank you. Please like, share, subscribe our channel for more such amazing videos. Thank you.